attention to this.
Apparently.
Okay, so let's play around. So I think before we do the sample, I got an interesting problem that Elvia brought in. And so let me write it down on my magic board here. There we go, magic pen. Let's hope, oh, it's not there. Darn it. Okay, so until I find a magic pen, I will type some stuff. Let's blow this up. All right, so let's see, what the source was FEMA on this? Okay, so FEMA claims that between 20% and 30% of Americans are prepared for some kind of disaster. Room disaster. Okay. So maybe they did a confidence interval, and that was their confidence interval. So let's the center of.
Oh, saying that I read about it.
They had a lot there. Yeah. So let's say this was their confidence interval. Then what would the center of their confidence interval be? 25%. Okay. So that's what they would call their p hat. Okay. So let's say they found, and we're going to actually call it p here. So let's say p is equal to then 25% according to their work. So Elvia collected some data to check on this, and in her data, so again, p here, this represents what's believed for the population. Population parameter.
I feel like I'm
Less people that are prepared, you think, for disaster? Yeah, I don't know. Well, we will know. So check this out. So Elvia did some research. In her research, she found that 27 people that she surveyed out of 100 were prepared for disaster. Now, then, you know, what does it mean to be prepared for disaster? Let's just not go. Let's say they were, we believe them, they're prepared.
in their opinions.
In their opinion. And then p hat, or p prime here, the book calls it p prime, would then be 27 over 100, so that's 27%. And let's see, what would q prime be?
73.
What, 63?
I'm 63, sorry.
So just double check, equals 1 minus this number right here.
No, it's 73.
Oh, 70, okay, so I need to have some more fun. Okay, so you guys keep a close eye on me today.
Yeah, I just grabbed that off the top of my head. I was
Good
right.
job, you were right. Yeah. Oh, I haven't have it written right there. That's sad. Okay, confidence level, Elvia chose was 96%. That means alpha is 1 minus that. And alpha over 2, our tail, is 2%, right? So draw a quick sketch of this. Percent. And I'm going to attempt to draw with my mouse. There's my best normal curve with the mouse.
Very nice. Beautiful.
Let's see, there's my highlighter. Let's see, hide that. Highlighter, oh yeah, pink is great. Pink for preparedness. Okay.
To computer, you can do that, I'm telling you.
Okay, so 96% is our confidence level. And so our tail, let's put the tail in yellow. That's our 2%. Are we going to calculate a Z or a T score here? Remember that flow chart we made the other day?
It's a sample for T.
Z? Right.
Z? Why Z?
Z, because it's a proportion.
It's a proportion.
Proportions are always Z's. So the deal there is we're not using the central limit theorem when we're doing a proportion. We're just using, what's the idea of a proportion? It's a binomial situation, and sometimes you can approximate a binomial with a normal. Okay? So it's just a different branch of the whole structure. If this was a mean, then I would probably use T because I'd be using a sample standard deviation. But if I'm not approximating a mean here, I'm approximating a population proportion. I'm turning a binomial into a normal, and I just use z-scores. So this is a z-score. Okay, so
So we use, the left tail, we use 2% for norm inverse, right?
norm inverse, yeah. So I'm going to calculate that here. So I'm using a z-score. So my z-score is going to be equal to the norm dot inverse. Probability is the 2% above.
Right.
Mean of a z is always 0. Standard deviation is 1. Now when I do that, it's going to give me a negative number because I'm looking at the left tail. So I'm just going to go back here and sneak a negative in front of normal in between the equals. So I get a positive version of it. All right, so about 2.05 is our z-score. So back on my table, so this z right here is about 2.05. That's a negative on this side and a positive on this side. What's the center of my interval going to be here for my population estimate? We're trying to predict the percent of the population, not the number of people. So it would be the 27 as a percent, not 27 as a number of people. So my center here is, I'll call it 0.27. So that's the center. And so next thing we need to do is calculate what is our margin of error? What's the distance that puts us 2.5 standard deviations out to the right? Okay. So margin of error formula. So I have it scribbled up on the board here, but I'll write it down here. For a proportion, the margin of error is equal to whatever your z-score is, so the number of standard deviations you want to be away from the middle, times a big old square root. I'm going to draw it just a little bit different than I did the other day. Take p prime, multiply by q prime, and divide by n, all inside the square root. So this is the way I would type it into a calculator or Excel. So let's calculate what our margin of error is. And sorry we're not in the lab today. I thought since I brought food, which you guys need to eat more of, come on, get sugared up here. Love these guys. The margin of error is going to be equal to my z-score times the SQRT of p times q, p prime times q prime, and then divided by n. And so Excel thinks our margin of error is about 9%. So
That's pretty good with a
96% confidence interval, we're within 9%. So if we wanted a tighter confidence interval, we would have to interview more people, like maybe another 100 people. We'll drop it down a little bit. So back to my picture here. So that means I want to jump 0.09 to the right. So that's going to be what, about 36%? This is going to give me a cramp in my hand any minute now. We want to jump to the left. I got to get a magic pen. 9%. Okay, I'm starting to die here. So this is 18 on the other side, percent? Okay. All right, so I'm gonna go run and get a magic pen because this is killing me. So you guys write a sentence as to what this means to my mother. And think about, does this match what FEMA says or contradict what FEMA says? I just had a vision in my head for the magic pennies. Right? Aha, it's in this little bucket here. Does it work? Oh, it works. Okay.
So we want to put it percentages, right?
Yeah, I would usually state it as a percent. So instead of calling it 0.18, I would call it 18% when I'm explaining it to somebody. Yeah. Okay, so this is one way I could state it. We're 96% confident that between 18% and 36% of Americans are prepared for disaster. I could state it by saying I believe that about 27% of Americans are prepared for disaster, plus or minus 9%. Right? We could always state the center and the margin of error. So if I stated that one. Did I ever hit record? I think I did, right? Yeah, it's recording. All right, we're 96% confident that 27% of Americans are prepared for a disaster plus or minus 9%. And I can't spell Americans. Oops. Oh, darn it. Stop that.
Is it not?
It doesn't.
No, I used to look camping.
Oh, well, yeah.
So I bought my plates and socks and shoes and food and jerky and flashlights and matches.
Now, when we
All right, so-
we make one of those,
Yeah.
do we have to do like all that work out then?
We always have a.
Yes.
Okay, and then you plan it.
Yes. Yeah. Oh, for your lab, right? Yeah.
Boy, no, for
Or-
the extra credit, you know, when you say makeup fees.
Oh, that's a whole different thing. I'll get to that in a minute.
Oh,
Yeah, that's totally different.
Oh,
Yeah, so there we're not looking for a confidence interval, we're just looking for a binomial problem. Okay, so yeah, I'll get to that next, as soon as I finish this problem. So is this consistent with what FEMA found, or is our sample like totally off?
No,
It's consistent, yeah, so FEMA says between 20 and 30%, we've got 18 to 36, FEMA's interval sits right in there. So they probably did something similar, but asked more people, right, and sampled different spots in the US. Some places that are maybe more prone for disasters, some places that aren't, is my guess. So that's pretty cool research. Congratulations.
The reason I said that I didn't think very many people would be prepared for disasters, everybody was so hyped up about the chemical depots since it's done and over with, and everybody's like, oh, nothing will happen ever.
Yeah, I remember. Do you remember years ago where there was a, I don't know, it was a radio show maybe or a TV show where they were telling, it was a TV show, the Tri-Cities I think it was, telling how to make a safe room with plastic and tape, ignoring the fact that you don't have any fresh oxygen, so if you put too many people in there, you're not going to make it more than a day because you need oxygen, and you're going to turn it into carbon dioxide very quickly. So I thought that was kind of silly.
And it's funny when you ask people how hesitant they are to answer. I think
Answer it?
yes or yes.
Because maybe they feel like, you know, you're going to think I'm a crazy person for having a room full of food, water.
Yes or no, that's all I need. I don't need to know what you have, or if you have, or where you, just yes or no. Something like, why me? Why are you asking me? Like,
You happen to just.
Yeah, right.
Yeah. All right.
my husband, why are you asking?
All right. So, new question related to this. What exactly do we mean when we say we're 96% confident? So if you could take a minute to write down a brief sentence to what you believe being 96% confident meant. Remember that quiz we took a while ago and I gave you 4 options? 3 of them were wrong. What does it mean to be 96% confident? Don't worry about getting it wrong, because I want to troubleshoot the things that are misbeliefs people have. So I don't care here about the 27% or the 18 or 36%. All I want to know is, what does it mean to be 96% confident? So here's one option. There's a 96% chance that the actual percent of prepared people is in our interval. True or false? False. What was that? It's false. It's not what that means. Okay, so if your sentence looked like that one, it's not true. So I'm going to make that red because it's not correct. Let's see what's another incorrect way I could try and say this. I'm stuck in, all I have is the right way stuck in my head. I'm having a hard time being wrong. Okay, so I'm going to state the right way. Maybe you guys can give me some ways that we can try and troubleshoot as being wrong. So what it means is 6% of similar samples will lead to confidence intervals that actually contain the real proportion. Contain the real proportion. Let's fix this typo. Okay, so 96% of similar samples. So that what that means is we would need a whole bunch of people like Elvia going out and taking samples and finding intervals like ours between 18 and 36. Okay? And they would all be a little bit different. Some of them might go from 21 to 35. Some of them might go from 17 to 34. And there'll be a whole bunch of different ones. So maybe 100 different people do that. So we have 100 intervals. 96 roughly of those intervals would actually contain the real percent of people that are prepared. And the other 4% would not. I have no idea if our interval in front of us today contains the real interval. No idea. And that 96% has nothing to do with that. This may or may not be one of those. But 96, so what it is confidence in our procedure, the way we're going about making these intervals. Okay? If I repeat this procedure of finding 100 people, and it's got to be 100 people, I always use the same number of people, over and over again, I ask 100 people, are you prepared? 96% of the intervals I create will actually contain the mean, or sorry, the proportion. But I don't know which of those 96 contain that and which don't. So this may or may not be one of them. Does anybody want to give me their sentence because they think it might be right or might be really wrong? So we can kind of get bad ideas out of the way. There's nothing wrong with being wrong.
I
Sorry I called you bad.
it's kind of close, but not really. It says being 96% confident means that of the samples taken, 96% of the data falls into that, right?
Yeah, it's not 96% of the data,
Yeah.
because that's not true either. It's 96% of the intervals we create will actually contain the mean. Yeah, so that's another common one that comes up, 96% of the data. And sometimes percentages mean that, but not this one.
Right.
Yeah, so it's not 96% of the data is going to be in this interval. Okay, any others people want to ask about to troubleshoot?
That if you repeat this many, many times, that 90%, 96% of those times, the true mean will be within those.
Yes, that works. Yeah, if you repeat this many, many, many times, 96% of those, the mean will be in 96% of those intervals that we create. Yeah, that's certainly another way to say it. But again, we have no idea which one, and there isn't a 96% chance it's in any one of them individually. That's not quite right either. So it's a little weird getting used to that. All right, so let's take a look at the sample final right now. Where did I put that? Here it is.
So does this cover all term or just the term?
This covers all term. Yeah, so if you notice, this first question is like the first several questions of your first exam. And then I jump into probability type stuff. And most of the probability stuff is binomial. That's the majority of the probability stuff we did. So in particular, check out these problems in section 4. And then go on to the next page there. There will be something like this on your final where I'm going to give you a bunch of different binomial problems. You just pick one of them to solve. Okay? You could do all of them if you really want, but you don't have to. Now, let's see, another thing about this is these were created by prior students of mine. So I'm going to give you an extra credit assignment. That assignment is to create an interesting binomial problem. Not a confidence interval, just a straight binomial problem. So example of a binomial problem would be, I read that between 9 and 25%, so let's call it like 50%, but 15% of homeless people are veterans from the US Armed Forces. So say I go out and survey 20 homeless people. Would it be unusual to find that 15 of them are veterans?
Yeah.
If I'm expecting 15%. Right? So that would be an example of a binomial problem. So not just a straight percentage, it's something you have to do some calculations and think about the answer. Okay? And so I want you to come up with a scenario that involves percent of some group, percent of people that have blue eyes, percent of people, homeless people that are veterans. Or you can go the other way around, percent of veterans that are homeless. That's going to be a slightly different percent. I think it's around 2 to 5% of veterans are homeless right now in the US, if you look at the other direction. Some other ones, 25% of Americans have brown eyes. That was one there. 32% of 85-year-olds have Alzheimer's. I think that's not right. Somebody made that up. I don't believe that percentage. That seems too high. But I could be wrong. So these are problems people made up. So extra credit, you make up a binomial problem, send it to me. I'm going to pick the top 5 problems that people submit to put on the test. When you take the final, you can solve any one of those but yours. Okay, because I'm assuming you already know how to solve yours. I want you to try somebody else's. And that's the other thing. Make sure you can actually solve it and that you believe your answer is correct. That would be important too. Okay, so I'll put mine up here just as an example. So I was reading statistics about homeless people, and I found that, and I found different versions of this number, so I'm going to kind of pick something in the middle. I'm going to say about 15% of homeless people are veterans. Okay. And so then my question would be, in a group of 20 randomly selected veterans. Not doing much better with this pen than I was with the mouse. Eraser, start that word over. Would it be unusual to find, let's say, I don't know, let's try 10 veterans. Oh, sorry, I stated that wrong. In a group of 20 randomly selected, that should be homeless people. That's our population. Would it be unusual to find 10 veterans? Let's see if we can solve this problem here. First thing I'd want to know in this scenario is what is expected? What's the expected value of this situation? Expected value of a binomial is n times p. So that's going to be 20 people times 15%. I think that comes out to 3. Is that right? So your calculator?
Yep.
Yeah, okay. So I expect out of 20 people to find 3 of them, on average in groups of 20 people, to be veterans. So I found 10. That's high, isn't it? Because then the question is, okay, 10 is high. So 10 vets is high. Is it unusually high? What do I have to do to answer this? No, I don't need to do that. So distribution-wise, if this is finding none, and this would be finding all 20 being vets, we think that the highest stack should be at 3, and then the stacks will drop down from there. And then they're just going to be wicked tiny out here. I'm aiming at, what? 10 right here. And anytime we do unusual, we have to do a tail probability. We can't just look at 10 out of 20. We have to look at, we have to find what's the probability of 10 or more. So, because our definition for unusual says, what's the probability of what you saw or more extreme happening? More extreme, since we are to the right of the mean, means keep looking to the right. So the probability x is greater than or equal to 10. Now, to do that, I'm going to have to use the binom dist on the computer. It only does left tails, though. Right, so I'm going to have to do a 1 minus to make this happen. The question is 1 minus what? X is less than or equal to. I want to keep 10 and above. What do I have to eliminate? 9 and below, yeah. So we always have, these are the trickiest ones to do right there. Those right tail binomials are the hardest. All right, so that means I want to do 1 minus the binom dist. So let me whip out Excel, see what I get. So this, I'm going to bring up a new tab, blow it up.
Thank you.
Okay, so I'm trying to find the probability that x is greater than or equal to 10. The same thing as doing 1 minus the probability that x is less than or equal to 9. Hopefully it doesn't freak out about that formula. It did. So we put a little apostrophe in front of it. All right. So to find that, I do 1 minus the binom dist. Number of trials here, or number of successes. What's the number of successes for this? So what is it? 9? Yeah, 9. Yeah. And then number of trials, 20. Probability of the success, 0.15. Yep. And is this cumulative or not?
Yes.
Yes, it is cumulative. Okay, so we are eliminating the left tail of 9 to preserve the right tail of 10 and above. Okay. And I get it's about like 0.03%. That's pretty low chance. So that's very unusual. If I'm expecting to find 15%, to find half of them are vets. Okay, so this is very unusual. So back here, so I just calculated this probability to be 0.0025, is that right?
Yeah.
Move the decimal place twice, 0.025. Whoa, get back there. 25%. Okay, so that is definitely less than 5%. And so this is very unusual.
Finding 10 deaths in a group of 20 homeless people.
Yeah.
Very unusual.
And then I'm just going to put a comment since we were expecting 15% of them.
I thought we were only expecting 3.
Well, yeah, that's the 3 is 15%. Yeah, so I could say since we were expecting 3, or I could say, yeah, so that might be more fitting here. We were expecting to find only 3. That works too. Yeah, so I want you guys to make up some kind of binomial problem like this. Notice I'm not making a confidence interval. I'm just saying, is this weird in any way to find that happen? Speaking of weird, we have a definition for unusual. Let's just remind, this is important. So for your note card, you definitely want this on there. So unusual events. So the probability, oops, start over. That's better. Of finding that event or something more extreme is less than 5%. And the key here really, oops, highlighter, is the or something more extreme part. That implies we have to find a left or a right tail. So the procedure that we just used here, so the first step really was to find the mean, the expected value. Then the second step is to compare your number to the mean. Okay? So if your number is less than the mean, that means we're going to do a left tail to the left. The alternative is that the number that you found is greater than the mean. So that dictates what step 3 is going to be. Whoa, back here. Sorry, the pen's freaking out. So for step 3, if it's less than the mean, that means you want to find the probability that x is less than or equal to your number. You need to do the left tail probability. Alternatively, you're going to find the probability that your number is greater than the mean or equal to, or sorry, if x is greater than or equal to your number, if your number was higher than the mean. We have to do a right tail. So the mean says this is what's normal. Our task is to say, okay, is this high or low? And then is it unusual? And so that would be, again, a right tail. So anytime we see the word unusual, immediately a flag goes up. Okay, that means I need to find a left or a right tail. Which one do I need to find? Come on, pen. There you go. All right, so let's see. What else should we try? Let's take a look at problem 6 on the next page. Come on, there you go. Okay, so problem 6. Let's blow that up a touch. Let's do that here. Adults have IQs that are normally distributed with a population mean of 100, population standard deviation of 15. What is the probability that the mean IQ of 25 adults is between 94 and 106? So let's see if we can solve that. I am going to attempt to copy that. So there's my little snipping tool.
That snipping tool is such a cool thing.
Okay, there we go. And we want this one right here. It is. Okay, we want to copy that into my notebook.
Number 6.
Did I copy the wrong one? Oh gosh, what did I do?
My bad.
Hang on, I just messed up the computer. Oh, I can write on the screen now. It's not what I want though. How do I get the regular thing back? Click here. Okay, edit, paste. Okay, there we go. Yeah, that's the right one. Pointer, resize. All right, so let's start drawing a picture of this. What kind of distribution are we working with? Normal distribution. All right. And what's the mean of this? Actually, before I get to the mean, what am I trying to compute a probability for? An individual or a group? A group, okay. If I'm using a normal with a group, what famous theorem do I have to apply? The central limit theorem, yeah. So the central limit theorem says that the mean of the means of groups of people is the same as the mean of the population. And it says the standard deviation of your average of a group of people is equal to the population divided by the square root of n. So I need to adjust my standard deviation here. So how many people do I have? 25? So my new standard deviation is going to be the 15 divided by the square root of 25. Okay, well, square root of 25 is 5. 5 goes into 15. That's 3 is my new standard deviation. Okay, so that's super important. So whenever normal things pop up, always ask yourself, am I doing an individual, in which case it's just straight information, don't mess with anything, or is this about a group of individuals? If it's about a group of people, we have to apply the central limit theorem. That means we have to adjust the standard deviation. All right, so now I'm ready to draw my normal curve. So here's my best one today. The middle for IQs is 100. And for a group of 25 people, the standard deviation is 3. So that means 1 standard deviation to the right would be 103, 2 would be 106, 3 would be 109. 1, 2, 3, that would be what, 91? 3 standard deviations to the right. This would be 103, this would be 97. All right, so we want to find the probability of being between, having the group be between 94. Okay, let's, if I subtract 3 again, where does that put me?
94.
Oh, look at that, 94 right there. And 106, well, check that out. 106 is exactly 2 standard deviations to the right. Well, can't we estimate this answer just by looking? What are we going to estimate the answer is here? It's going to be about 95% from the empirical rule. So it's approximately 95%. And we should do the calculation to confirm that. So on the computer, Excel, I would type, what is the norm dot dist? And the computer has the problem, it only does left tail, so I can have to do a subtraction. Take the bigger one first, 106, with a mean of 100, a standard deviation of 3, and this guy is always cumulative, never a 0 on the normal dist. And then from that, I'm going to have to subtract the lower tail. Norm dot dist of 94, comma 100, comma 3, comma 1. And so remember, on the test, I'm going to be hoping to see a picture like this. I'm going to hope to see you write down your formula. And then I just need the answer and what it means. So let's have Excel whip out an answer on that. Let's just stick it right here, right there. So this is equal norm dot dist of 106, comma 100, comma 3, comma 1 minus the norm dist of 94, comma 100, comma 0, comma 1, comma 3, comma 1. I think I got this right. And it says 95.45%, which is what the empirical rule says it is, roughly 95%. So we're good. So I'm going to call it 95.45%. And then I'm just going to make a brief statement about what that means. There is a 95.45% chance that the average IQ of a group of 25 people, 25 adults to be more exact, is between 94 and 106. And this is going to be a lot like the problem above, except the problem above this one says it's just an individual. So that means we would stick with 15 as the standard deviation. Okay? So if I were doing the problem above this one, number 5, in Excel, all I would have to do is go in here and change the standard deviation from 3 to 15.
15, 3.
So the problem above, we would get about 31% chance. So for problem 5, there's about a 31% chance that a randomly selected individual has an IQ between 94 and 106. That's what that tells us. So that's for a randomly selected individual. The other one is for a randomly selected group of 25 people on average IQ. All right.
Number 7.
Sure. Let me just write this down. 31.08%. 95.45%. All right, number 7, let's take a peek at it. All right, a study involving stress is conducted among the college students on the campus. The stress scores follow a uniform distribution. Anybody remember the shape of a uniform distribution?
Isn't it like a box?
It's a box, it's just flat. Yeah, just flat, kind of like rolling a dice, you get 1/6 chance of getting any particular number. With the lowest score equal to 1 and the highest score equal to 5. Using a sample of 75 students. Okay, so we're taking a group of 75, we want to find the probability that the mean stress score of those 75 is less than 2. So once we say we have a mean of a group, it's central limit theorem. That's what's going on there. Do I give enough information to solve this? I do not. We got to look up a formula in the book. Because what do we need to be able to solve this problem?
I asked.
We need the mean and the standard deviation. The mean is going to be pretty easy to find. So let's see, we have a uniform distribution.
What does that mean, just a flat distribution?
Yeah. Distribution. And so that means, so here, so this would be the stress score on this axis. Stress score. They said the lowest stress score you could get is a 1, and the highest stress score you can get is a 5. Now, it doesn't say the stress score has to be a 1 or a 2 or a 3, so I'm assuming you get a stress score of like 1.5 or 1.7. So that means this distribution would look like this, where the area inside this rectangle is 1 or 100%. Now, it's not a huge deal to know the height of this box, but I can find it. The distance between 1 and 5 is what? 4. So that means the height would have to be 1/4, because 4 times 1/4 would give me an area inside of 1. I don't really need to know that. It's just a little fact about that. We skipped this chapter in the book, so.
So is this going to be on the test?
If it were going to be on the test, I would have to give you the mean and the standard deviation. Now the mean we can find real easy. What number is in the middle here?
2.5.
2.5 or 3?
No, it'd be 3.
It'd be 3, yeah. 1 plus 5 is 6, cut it in half. So 3 is exactly in the middle. That's the mean of this distribution. Standard deviation, I can never remember that formula. I always have to look it up. So let's go to the book and look it up. Web book.
Yeah, I will. Wait.
Okay, so I'm upping your stress by doing this problem. All right, so we want continuous.
I read that and wrote uniform distribution and number and mean and a little line. And
Yeah, so here in the book, to get the formula, we just go to uniform, continuous, uniform, and we just want to know what the formula is for standard deviation. Okay, so here's the formula right here. So we take the difference of the endpoints. So 5 minus 1 is 4. Then we square that and we get 16. So we want to take the square root of 16/12 to get that. Write that down. So the mean, that's there. Standard deviation, that's sigma, is the square root of 5 minus 1 squared over 12, which is the square root of 16/12. So let's ask Excel.
1.15.
1.15?
Yep.
Okay, we'll go with that,
Why is it 12? What is the 12?
because that's what the book says.
Okay.
That's not a good answer.
That's the best answer I can give. Sorry. We'd have to do some calculus to justify why 12.
12?
Yes.
Okay.
If it's a uniform distribution, it's always take the difference of the endpoints, square it, divide by 12, take the square root. End of story. If we wanted to justify that, we'd need to take some calculus. But let's not do that.
no, we
Okay.
don't do one.
Calculus is almost as much fun as stats.
Oh, no.
So what is
That's
this,
a lie, Gary. That's a big fat lie.
1.15?
1.15.
1.15, okay.
1.155 if you wanted to get more.
Let's throw another decimal, what the heck. All right, so that's about the population standard deviation. The central limit theorem says we need to tweak that. So the central limit theorem says to get the standard deviation of a sample, take that standard deviation, 1.155, and divide by the square root of the sample size, which is what?
75.
75. What do you got for that?
For sample size is 8.66.
Okay,
No, you have to do that.
so next we do division.
Oh, shut up.
What 75 came from?
That, we were told there's 75 students in our sample for number 7.
7.
Yeah.
Okay, yes.
Point 133. Point,
No, I'm pretty.
yeah.
133. Okay, so let's go with that, for that one right there. So now, I want to find, so I have all the information I need. Now I want to find the probability that the stress score for a mean is less than 2. So this is a normal problem, so I'm going to use the norm.dist. The mean of this, let's see, what does it want first? It wants my x value first. What's our x value here?
2.
2, or our x bar, our mean is 2. What's the mean of my uniform distribution according to the central limit theorem? 3, yeah, that stays the same. The standard deviation according to the central limit theorem? 0.133. And is this cumulative?
Yes.
Always for a normal, always. And again, this is a left tail, so that's pretty straightforward. I just type that in.
So if you give us this on a test, we'll have,
I would have to give you the standard deviation also.
okay, so
Yeah.
it won't be this hard.
No, we won't have to look that up. So I want, again, the probability that x bar is less than 2. Oops, whoa. And that's equal to the norm dot dist. X is 2, mean is 3, standard deviation is about 0.133. It is cumulative. And so I get a wicked little number. So what does that number mean? Boy, did we do that right? Yeah, that's right. Okay. Let's call that a 3. So then this answer is approximately 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 3. Which the book, how would the book refer to that number?
0 plus.
0 plus, yeah, it's like close to 0 as we ever want to get. So it's very unlikely the stress score is going to be less than 2. Check. Where did I get this problem? I have no idea. Okay,
So the 90th percentile for the mean stress score for 75 students.
Yep.
And we would just do that.
okay, so 95 percentile. So again, when we look, although an individual student has a uniform distribution for a particular stress score, a group of people would have a normal distribution. So my picture here would look something like this. The mean of my distribution is 3. I'm talking about a group of 75 students, so I have to use the standard deviation of about 0.133. So if I went, say, 2 standard deviations to the right, that would be about, come on, pen, 3.266. Right. And just thinking about this for a second, 2 standard deviations on each side, that's 95% roughly of the data. So that means this right here would mark 95 plus 2.5, or how much percentage? Right, 95% of the data lives here, right? What percent is in this tail over here? 2.5. So then total from here down would be what?
97.
Yeah, so this would be like the 97th, 98th percentile. So my point is I'm looking for what, the 90th percentile? So that's gonna have to be below this somewhere. Okay, so the number I'm looking for is somewhere over here, I don't know where. So P90. What formula do I use to find a percentile? Norm inverse, right? So we're gonna ask the computer, what is the norm dot inverse of 90%, that's 0.9, mean of 3, standard deviation of 0.133. Let's ask Excel. So P90 equals the norm dot inverse of 0.9, 90%, comma, center is 3, spread is 0.133, and it says it's about 3.17. So a stress score of about 3.17 is the 90th percentile for a group of 75 students. Let's see. 3.17. So sentence, what the heck does that mean? A stress score of about 3.17 is the 90th percentile for a group of 75 students. And I'm missing a word here somewhere. Let's see. For the 75 students, I'm talking about their average, so I have to squeeze the word average in. So that would be in the beginning.
An average stress score.
An average stress score. So an average stress score of about 3.17 is the 90th percentile for a group of 75 students. That's what we got. And so if this one were on the test, I would tell you the mean is 3 and the standard deviation is about 1.155. All right. Let's try 9 or 11. What time is it? We have time for both. Let's do number 9. Copy that to a new tab. Let's see if it'll work this time. Okay, so let's see. In problem 1, I gave the IBU, which is International Bitterness Unit, measurement for 32 India Pale Ales. Histogram suggests that the population has a distribution that is approximately normal. Find the margin of error for a 98% confidence interval. And here I'm actually giving you the t-value. So what does it mean if I'm using a t-value? What's that? That means I'm using the sample standard deviation. I don't know the population standard deviation. Yeah, so that's what that means. So that means I need to look back at page 1 to see what is the mean and standard deviation of this sample. So looking back at page 1, I calculated a sample mean of 67 and a sample standard deviation of 13.2-ish. Okay, so 67 and 13.2. So back here, there we go.
So we need a T-score, is that what you said?
Yeah, and I provide the T-score right here.
Oh,
So otherwise on this Excel, we would have to do inverse T. And I can double check that too to make sure I didn't mess that up, but I probably
What is the 0.01 next to T? What is that?
So yeah, let me write that down. Hang on, let me write these down. Let's see, S is equal to 13.2. Okay. Call coming in. So quick, I just want to draw this. I'm doing a 98% confidence interval, right? So as far as T-scores are concerned, 0 is in the middle.
Also,
It's the
1%
tail
on each
probability, yeah. So we have 98% in the middle, confidence level 98%. So that implies the tails have to share 2%. So alpha over 2 is 1%. And so, oops, get confused. 1%. So this value right here is referred to as T.01. And that's the number I'm calling negative 2.453. This guy right here would be positive 2.453, right? And that guy right there would be T sub 0.99. So it's like a percentile reference. Except we stated as a decimal. All right, so does anybody remember how to find the margin of error for a situation like this?
Is there a C-score?
Almost Z, this is a T
Oh, that's
instead.
a T.
Yeah, so this is a T. Now this one on the board here is for a population proportion,
Yes.
but it's got some similarities.
the
T-
T inverse.
What's that?
It's the T inverse.
Well, the T inverse calculates this T value, and I did that for you.
Is the Z times P.
That's a
prime
proportion. We're not doing proportions here.
proportion.
T times S.
Times
over-
S
Or
over the square root of N.
Oh,
over the square root.
So for us, that's going to be approximately 2.453 times S, which is about 13.2, divided by the square root. I think there were 32 beers in the sample. Yep. Divided by the square root of 32. So that number, whatever it is our margin of error. Let's find that. So whip out your calculator. I'm going to double check this on Excel. So 2.453 if we round, so that's the T-score. I'm just confirming that. And I got that by using the T inverse formula. I'm using a left tail of 1%, 31 degrees of freedom, because there's 32 beers in the sample. Always one less there. And then the margin of error is going to equal that number. I'm going to negate it times S, 13.2, divided by the SQRT of 32. And my answer might be a little bit different than yours because I have a slightly different rounding, 5.7-ish. Yeah, okay. So we're getting a margin of error of 5.7-ish. Now our data here, if we look back at the original numbers, they're measured in whole numbers. So that means in my final answers, I really only need 1 decimal point. So I would call the margin of error 5.7 in this case. All right. So what we have, having a center of 67, because that's the mean, we're finding our spread is approximately 5.7. So that means on this side, what's that, 72.7? And then we subtract 1.7 to get our margin on the other side. 61.3. Help me out, someone.
Okay.
I think that's 61.3. Now, the hard part. What does this all mean? How do I tell my mother or my stepdad? What does this mean?
96% confident that between 61.3 and 72.7
Is the bitterness rating of
India
Pale Ale? Okay. So, well, no. I got this from the data for 32, but I'm trying to predict on average what, if I randomly grab an India Pale Ale, about what should the bitterness rating be.
Between.
And we're finding that we're 98% confident that the bitterness rating is going to be somewhere between 61 and 72 or 72 of any beer in general.
I expect the bitterness of any IPA in general to be.
Actually, it's the average bitterness. Yeah, it's average because we're trying to find the mean of the population is what we're doing here. So looking back at the original problem, let's see. We want to find a confidence interval for the mean IBU for American India Pale Ales. So writing my sentence, switching color. So I am 98% confident.
Yeah.
That the average IBU of
Take me
an
nowhere. Sometimes. There's me up, you can't take me out.
oops.
That helps.
What is India Pale Ale?
Gross.
It's a wonder. It's my favorite beer.
Headache beer. I can't
Headache
believe you
beer.
drink it.
It's between
I
61.3
that stuff home, my husband.
and 72.7. I think hops might be as addictive as sugar.
You're probably right.
Because I don't like, since I started drinking hoppy beer, I don't like beer that's not hoppy
Really?
very much. I used to love stouts. I'm not as much of a fan of stouts anymore.
Yeah, I like stout.
Stout's a great beer. It's good for breakfast, lunch, dinner.
Yes.
Just kidding.
I could think
Just disclaimer, do not drink more than one stout or India Pale Ale if you're about to drive, or do math, or play with an infant.
What?
So 3 things you should not do while intoxicated.
Worried.
What's another way I could say this here?
So like the 67
Yeah, you
plus
did
or minus.
Yeah, I could say, the average bitterness rating is about 67 plus or minus 5.7. Yeah, that'd be the other way to say it. All right, should we do another one of these or something else? What do you guys want to do? Excellent, let's do another one of these. Number 11. So take a read through number 11. I'll bring it up here on the board.
You're
Let's
gonna post
see,
the answers to these, right?
eventually.
Sooner than later.
Well, as soon as I find time to write them. Do you have a copy of this already? It's the one that's on
I
the
don't.
website. You need one too? Okay. Okay, just go on. Okay, so get closer.
Exam are on Tuesday, right?
Yes, we're gonna do the exam Tuesday morning.
Like, can we have notes on that one?
What?
Can we have notes on this?
Yes, you can have a page of notes, just like the last one, whatever you want to write on it. It's got to be created by you. Okay, so you can't like take my answer key from the final.
Okay, what if we
Bring
write it
that.
down?
If you write it all by hand, that's totally fine. You could totally do that. So, but you can't, that would be plagiarism, right? To use my notes as yours without my written consent. Okay, so let's see, what am I doing? I am copying problem 11. Okay. Snip. Copy. Paste. Okay. Oops. Wrong button.
And what I think it would be,
What do you think?
don't be a line through it.
Okay. So it's estimated that 19% of US drivers access the internet on a smartphone while driving. Ooh, that's bad. That's like right up there with drunk driving. To test this claim, a curious statistician took a random sample of 56 adults.
Sounds like what Gary would do.
This sounds like something I would do, yes, and I actually did do this last year. Not drive while accessing the internet, I actually surveyed 56 adults. Okay, and I found that 13 of them admitted to driving while accessing the internet on their cell phone. Right, so they're driving on the road and they're searching for something on their phone at the same time. It's right up there with texting on your phone. Don't do that. With a confidence level of 95%, I want to test the claim that 19% of smartphone users access the internet. Okay. So this is kind of like what Elvia did. She saw this claim online for what this percent was, and then she went out and did her own sample and says, does my sample match what these other people think? Okay. So for now, we're going to ignore the 19% and only focus on my data. And my data says 13 out of 56 people access the internet while driving. So we want to make a 95% confidence interval for that. Go for it.
What did you say?
We want to find a 95% confidence interval based on a group of 56 adults, 13 of whom did a bad thing while they were driving. Access the internet on their cell phone. Let's see, pen back. So important information. X equals 13. N, 56. Confidence level, 95. Things we want to know. What is P hats? What is Q hats? Or Q prime? What is alpha? Alpha over 2. Draw a pretty picture. If you need help with the calculation, holler at me.
No, yeah, question form or investment form?
Either way, whatever floats your boat. Yeah, so as a fraction, it would be 13 out of 56. As a decimal, we'll have to start rounding stuff. So let's whip out Excel.
We gotta figure out the margin there. and all that stuff.
Yeah, so I'll need to help you guys with the z-score. So what percent is the z-score going to be based on?
I believe.
Alpha is what? 5%.
0 point.
So yeah, alpha over 2 is 0.25. So for my, oops, so I'm just going to calculate the z and just give it to you. Whoa, stop that. So that would be equal to the norm dot inverse of this number cut in half, comma 0, comma 1. So Excel says the z-score is about negative 1.96-ish.
Wait, so, I guess I still don't understand exactly when you use T or Z
Okay,
without looking at my paper. Like,
so Do you want me to re-flow chart it?
We did a flow chart.
Yeah,
You did a
that's,
flow chart.
that's the only way I know,
Right.
is with looking
Then
at
put
that.
the flow chart on your cheat sheet.
Okay, so don't learn anything in five.
It's just easy.
Yeah, so then the flow chart again, we're either finding a mean or a proportion. If we're finding a proportion, we're going to use z-scores. For a mean, if we know sigma, then we use z. If we don't know sigma, we have s, and we use t. So that's like the most abbreviated form I can give you, the flow chart. And so we are in the proportion section, which means we're using z's.
And what was that piece for you guys?
About 1.96. Margin of error in a scenario. So I found, so if this is z-axis, that's 0. This is negative 1.96. This is positive 1.96. What was 13 over 56? Like 23-ish percent? 23.2. So this is about 23.2%. So that's the middle of my interval. Now I need to figure out what's my margin of error to jump me out to the edge. So the margin of error, in this case, is your z-score times the square root of p prime times q prime divided by n, inside the root. Another formula you want to put on your cheat sheet. So I'm going to ask Excel about that.
When we calculate these, do we calculate them as like whole number percents or point?
Yeah, so
I got confused when I was working.
so for example, inside my square root, if I just type something like 23.2, that would be totally wrong because I'm missing the percent symbol.
Right.
So I would want to type it as a decimal.
Okay.
If I'm in Excel and it has the percent symbol on it, I can just click on it.
Oh, okay.
Yeah, so we have to be super careful about that.
So,
Since this is a decimal, I can just click on it. Even if it was in percent form in Excel, I could still click on it. What would be bad would be like right here. If you typed a 27 and a 63, when you mean 27%, you're totally screwed up because the computer's missing the divide by 100s, which will mess up everything. Yeah. So generally, I use decimals if I'm doing it on a regular calculator.
okay. Because I know I did it both ways, and the number is really 60% or very.
Yeah, I got like.
Basically, your answer will be 10 times greater than it should be if you don't do that right.
Yeah.
Is that right? No, 100 times greater than it should be. It'll be 100 times greater than it should be
Right.
if you plug it in wrong. Yeah. So I'm getting a margin of error of 0.11. Anybody else get about that? No?
Uh-uh.
Oh, shit.
I got 0.0006.
Yeah, I got
0.00 z times the square root of p.
P times Q
Oh, I
divided
forgot to
by,
do everything, actually.
yeah, you gotta have all that in the square root. I get it's about 0.11.
I must have put it in
So I could double. Okay, yeah, I'm 99% confident that's correct.
Now I got
it too.
Okay, yeah, so you forgot the square root?
Yeah.
Okay. Yeah. So if I were doing this on a handheld calculator, I have to be a lot more careful. You're gonna have Excel in front of you on the,
So mine shows
test.
a negative.
yeah, that's because you use the negative for Z, but we always interpret the margin of error as a positive value as we add or subtract it. Yeah. So, and I adjusted my formula by sneaking in a negative in between after the equal sign to counteract the negative here. If I forgot to do that, no big deal. I know my margin of error is actually 11%, not negative. It's a positive idea. All right, so we think the margin of error is about 11% from 23% roughly. So that means I want to head that 11 to the right and 11 to the left. So let's put that in the picture here. So margin of error is approximately 0.11. And so then over here, that's going to jump me up to what, 34% roughly? And down here, what's that, 12.2% roughly? Okay, so what does that mean? So I'm 95% confident that the percent of people who drive while accessing the internet on their cell phone is between 12 and 34%. Between 12 and 34% of people access the internet on their phone while driving. And they should get the finger. Bad, bad, bad. Don't
I usually give those people different fingers.
What's that?
So I usually give those people a different.
The other finger, right? Yeah. Okay. So the and I can't remember what website I found this on. I got to look it up again. But the website I was on said 19% of U.S. drivers do this. This was as of last year, 2014. Does my confidence interval confirm or contradict their finding? It confirms because it's inside of my interval. Yeah, 19% is definitely in my interval. It's in this lower part here. That confirms my research does not contradict theirs. And so that would be my finding. I would state my sentence, what does the interval mean? Then I would say 19% is well within my interval, so I believe them. Did you guys ever read something that you're like, I don't believe that many people? Right? I read that stuff all the time. Now you have the power to test it. Isn't that awesome?
It's awesome.
All right, so what else should we do? A binomial problem, maybe?
A what?
A binomial problem?
Yeah.
Look at the top one on page 2.
The Valentine's Day dumping?
Yeah, the Valentine's Day dumping problem. This is not real. This is one my student made up last year. I thought it was funny. So let me find the problem. All right. According to a recent survey, 50% of women dump their boyfriends on Valentine's Day for not getting them something. So I actually think one of my students actually surveyed college, I think they did more than college students, but they surveyed people to say, if you didn't get a Valentine's Day present from your boyfriend, would you dump him? And 50% of the people he surveyed said, yes, I would.
Wow.
So fortunately, my wife is not one of those women because I can be a little absent-minded sometimes. I usually don't forget Valentine's Day. All right, so in a random sample of 80, would it be unusual to find only 25% were dumped?
Only 25.
Or only 25, sorry, yeah, 25%. Only 25 out of 80 were dumped. Okay. Now, so 25, that would be low, wouldn't it?
Yeah.
Yeah, because we're expecting half of them, so 40 would be dumped. So is it unusually low? That's the question. Is it ridiculously low that I don't believe it? If 50% is right. Okay, so let's check that out. So scratch paper here, new page. So we have N is equal to 80. P is equal to 50%. The expected value, mu, right, that's N times P, which is 40. So we expect 40 boyfriends that didn't get their girlfriend's Valentine's Day presents to get dumped. We found that X was equal to, is it 25? Okay. This is low. Observation, it's low. There's no doubt about it. It's not what we expected. So is it unusually low? To answer that question, we consider that in a group from 0 to 80, we expected about 40. So that should be the highest stack. And then it's going to drop off from there. We are way over here. 25 is probably about right there. So that's 40. This is 25. Since it's low, we have to check the whole left tail. So to see if this is unusual, I need to find the probability that X is less than or equal to 25. Now left tails are nice and easy. This would be the binom dot dist. X is 25, N is 80, P is 0.5. This is definitely cumulative because I'm doing a tail. And so I need to whip out Excel and ask. Do you think it's going to be unusual? Any guesses?
No.
No, I don't think it will be.
Okay, I think it is, but I don't know. All right, so the probability that X is less than or equal to 25 is equal to the binom dist of 25, 80, 0.51. Oh, it is unusual. We get 0.05% chance of this happening, if I
That's sad.
calculated that right. 25, yeah, I plugged it in right. It's definitely cumulative. So that's the probability of finding 25 or 24, 23 out of 80 got dumped. Should be higher than 25 if we expect 40.
What was your answer?
My answer was 0.0005. So 0.05%. Yes, it is unusual. So this equals 0.0005, which is about 0.05%. So yes, it is unusual. Oops. All right, one more, or have you had enough?
Just out of curiosity.
Sure, let's take a look at that one. So that would be problem 4A.
Okay, never mind. We did that one first.
Did we? We didn't, I mentioned it, we didn't do it though.
You just mentioned it. You didn't
Yeah.
think it.
We can do it. All right, so let's take a peek at that one. All right, suppose that 32% of individuals 85 years and older have Alzheimer's disease. Now again, this is fictitious. A student brought this to me. I never confirmed any of this.
What number is this?
This is 4A. You go to a nursing home that has been feeding residents a diet consisting of natural, organic, and healthy foods, including free-range chickens, omega-3 eggs, flax seeds, etc. You find that only 23 out of 113 of these 85 or older people have Alzheimer's. What's the likelihood of this outcome, and is finding 23 out of 113 unusual? So this question actually has two different questions to it, two different parts. All right, so start writing some stuff down. I'll put this on my scrap paper and see what we can come up with. What am I doing? 13 is N, right? T is 0.32. So mu equals this times we expect to find about 36 out of 113 people to have Alzheimer's. So is finding 23 high or low? Yeah. So X equals 23 is low. First question they ask is, what is the probability of finding exactly 23 individuals? That would be if it's normal. This is binomial, so there is a chance of finding exactly 23. So first thing we want to do is, because they ask for what's the likelihood. Likelihood just means probability. So that means we would just want to find the probability that X equals 32. Since this is binomial, that can happen. So this would be the binom dist of exactly 23 out of 113 when we're expecting 32%. And since it's a single number, it's not cumulative. That would be a 0 there. So for the first question, there's about a 0.2% chance of finding only 23.
Formula back up, please.
Yeah.
Yes, thank you.
Oh. There we go. So there's 0.2% chance of finding exactly 23 out of 13 people in the nursing home with Alzheimer's.
Oh, that's what I do. And the answer was
0.2%. Next question, to answer if something is unusually low, do I want to do a left tail or right tail? Left tail, okay. So that, then to answer the next question, I need to find the probability that X is less than or equal to 32, or no, 23. Oops, did I type the wrong number up there? This should be a 23 here. Right digits, wrong order. Oh, this problem's horrible for somebody with dyslexia, isn't it? There's a 23 and a 32 in it, or Alzheimer's, yeah. Okay. So that would be equal to the binom dist. X is 23 again.
Mr. Parker,
Yo.
I had a question.
Yep.
It might seem dumb, but, okay, so how do, like for me, since I don't really get it really well.
Yeah.
You put for the cumulative 0.
Yeah.
So it's not cumulative?
If you're trying to find a single number, it's not cumulative. Cumulative means less than or equal to.
Okay, less than.
Yeah. So if it's a binomial and it says equal to, the last number is going to be a 0. If it says less than or equal to, the last number is going to be a 1. Because that's what cumulative means, less than or equal to. We'll do a variation on this problem to do one more version of that. So I'm going to type a 1 there. And so if I take, so this is the probability of finding 23 or 22 or 21 and so on down. So this is 0.4%. Is this unusual?
Yes.
It is unusual. Okay. Now, this problem was implying, where'd it go? That these older people are different than others because they had a different diet. They had a much healthier diet. And somehow the claim is then that diet makes Alzheimer's effects or the disease more rare. So it is unusual. So the person who wrote this was trying to imply eating a healthy diet could save you from Alzheimer's.
Mr. Parker, could you put it back?
Yeah, to my notes. Yeah. Oops, Excel, here we go.
Oh, yeah.
Yeah, I can get the formulas up. I'll hang on one sec. Oops. So there's one formula. And there's the other. So if it's exactly some number, it ends in a 0 for that formula. If it's less than or equal to, it's going to end in a 1. Let's do a variation on this problem, and then we better stop because I got to get to another town. Let's suppose instead I said I found 40 people. Is finding 40 out of 113, is that high or low? It's high because it's above the mean. Okay. So what? Is it unusually high? What probability would I have to find to answer the question unusual? The right tail. So I want to find what is the probability that x is greater than or equal to 40. Now, can I do the right tails directly with the binomial formula on Excel?
No.
No, it only does left tails. So that means I need to do 1 minus some left tail. That x is less than or equal to what? 39. Yeah, we want to keep 40 and above, so we ditch 39 and below. So we're going to take away 39 and below. All right. Oops, I know you don't like that Excel. Okay, so to do that, oops, I'm going to do 1 minus the binom dist of 39. Oops, what the heck?
That was so weird, but you went with it too.
39.
It's strange.
Did someone just say that number? Or-
No.
No, I'm just
I think
being,
your hand is on the row lower on the 10 key. 3926.
oh, yeah, maybe, I don't know. Or I have Alzheimer's. 113, probability is 0.32. And is this cumulative?
Yes.
Yes, it is, good. And so I get 24.8% chance of this happening. Not unusual, this can totally happen. If I'm expecting 36 out of 113, we could very likely find 40 or more.
Can I see a formula for that?
Yeah. Oh, sorry. Yep. Okay, hang on. So our final is going to be Tuesday morning. Shall we do 8 or 9?
What?
9? Okay, 9 o'clock.
Don't be changing the schedule now.
Okay, so 9 o'clock. And I am going to come here Monday night for a study group. I was planning to come at 5 unless somebody wanted me here a little earlier. I know Tanya said she might not be able to do that. What time are you going to work?
I don't know.
Don't know. Elvia, can you do that?
Yes.
You can? Anyone else have a
Yeah.
problem? I might want to try to adjust. You're swing shifting it then?
I think so, yeah.
What's that mean? What time
I
is
have
that?
swing shift, 2:30 to 10:30, so I won't.
Every day?
No,
Oh.
I think just on that Monday.
So on, just if this helps, on Sunday in Pendleton from 5 to 8, I'm doing a study session in Emigrant Hall. So if you can't make the Monday or you want to come to 2, so Monday 5 to 8, no, Sunday 5 to 8, Pendleton, Monday 5 to 8 here. That's my plan for study.
Monday,
groups.
5 to 8 here.
Here, yeah. Monday I'll be here because your exam's Tuesday morning. Sunday I'll be there because their exam is Monday morning. Yeah, and then let's see, today's Thursday. Tomorrow's Friday. I'm planning to be here all day tomorrow.
What time are you gonna get here Friday?
I'm gonna get here about 9 on Friday. The lab for the lab crew in the afternoon is just review stuff. So anybody, even non-lab people, can come for that if they want. So I'm gonna be here.
We're not gonna have tests in lab, are we?
We're just doing review. Yeah, so I'll be here from 9 to 3:30 tomorrow.
Review on.
Whatever.
What's the
Review on the.
The review for the final exam.
Okay, then.
So lab 9 is due tomorrow, right?
Yeah, so what I'm expecting lab 9 tomorrow is that you come out and say, this is what I surveyed about, here's what I found.
Like we're gonna have to present it?
No.
Oh.
Well, you're gonna have to give it to me so I can at least share it.
Oh.
I want everyone to hear about what the research was. You can present it if you want, otherwise I will. If you'd rather not.
I don't know.